Hi, and welcome to this video. In this tutorial, I'm going to show you how to aggregate rows from a database using Java HStreams and Speedment. So if you have followed along in the previous videos, you've seen that I have set up a simple application and used Speedment to generate entities and managers directly from the database metadata. So in this example, as we left off in the previous video, we had created an application, and then we had retrieved the manager or the salary table from the Speedment application. We have streamed over that, filtered out the salaries between $60,000 and $80,000, and then counted them. And then we print that to the log. And this is a completely type-safe way of expressing a database query. So if I run this, you remember that it told me that I had a little bit over 1 million salaries in that span. But that doesn't really tell us very much, because what we're doing here is we're doing one single count over an entire stream. But in a real use case, you often need to do more than just one operation on the results. So of course, I could collect this entire thing into a list and then do multiple things on that list, but that wouldn't be very performant. I want to perform everything as few operations as possible. So say that I wanted to compute, say, the average salary in that span. There is a built-in method in Java called average on IntStream. So I could use that and write something like, say, double, and then we rename that into average. And then I say, I want to map these results into a int stream using salary, because the Speedment fields also implement toInt function. And then I could say, instead of count, I could do average. And then since the stream might be empty, there is the possibility of having a stream with 0 elements in it. So I have to specify how to handle that case. And in this case, I can just say, or else 0. And if I run this, I mean, it works. It gives me the average, something around 68,871. But it still doesn't allow me to do more than one thing. I can either count the average or I could count the total number of, but I can't do both at the same time. So that's why in Speedment we created something called the Aggregator. It's a system for collecting streams into different operations. So you might want to do both the average and the count, or both the average and the variance, for example. So I'll show you how to set it up. So first off, instead of doing the average and or else here, I'm going to remove that, remove the map to int, and then say .collect. And then by default it says toSet, but I'm going to remove that, and instead say I want to collect using an aggregator. And then here, this uses a builder pattern. So it asks me for how to create a result object that will hold the values that are coming out of the stream. So in this case, I want to count both the, say, the average and the variance of this set of data. So I'm going to create a folder class here, private final static class result, and then add 2 fields, a average and a variance. And then I can let IntelliJ generate some setters for me, and a toString method, like that. So now when I have that, I can say that this is how you create a result object. It's a result : new using a lambda. And then I can start specifying what I want to do with this aggregator. So I first want to compute the average number of salaries so that I get the same result as I had before. So I say on salary average, salary, and then average. And then it asks me what to do with the result. And I just say result set average. So now I've added one operation to the builder. And I could go on and just build this right now, and it would give me a aggregator as a result. And an aggregator has a single method called createCollector. So now we have created something that should work. Just doing one operation, but we could just as well continue adding operations here. So we could say on salary again, and then say variance this time, and say result set variance. Now we have an aggregator that performs 2 different computations on all the data that's coming in. And it's doing this in a streaming fashion, so it's never materializing the entire list while doing this. So it's very convenient. So if we take this and just introduce a local variable, we'll see that the result from this is an aggregation. And an aggregation has a few different methods. It has a stream and close, a stream, and a close. So if you want to do, you could stream multiple times over the result of this, and then you could wait with closing the result until you're done. Or you could just stream and close in one single line, and that's what I'm going to do here. Take stream and close, and then for each system out print line, because you remember we added a toString method here on the result. And here we can see that we counted the average, still the same as before, but now we also have the variance here. So that's it for this tutorial.